knowledge of physics. In this video, I will be showing you finding out the derivative of function log of sine x divided by a from first principle. So let's get started. Please stay with us till the end of this video. To find the derivative of this function from first principle, we have to first of all suppose let this function be denoted by y, and it is log of sine x divided by a. Let this be equation 1, and let's take antilog. If you take antilog on both sides of this equation, we get as exponential y is equal to exponential log of sine x divided by a. Okay, and here we have to use the property of exponential function and log function, as you know, if exponential log x be our function, then you can replace it by x. This x comes inside out of all these two functions, because if you consider log base is e or exponential, and this is also base, so it becomes x. And same case is here we have considered base of this log function is exponential e, which is denoted by this e as well. So this sine of x by x divided by a comes out of log and exponential function as this. Okay, so exponential y is equal to sine of x divided by a. Now let's substitute sine x divided by a is equal to t. Okay, in equation 2. Okay, after substituting sine x by a is equal to t in equation 2, we get exponential y is equal to t. Let this be equation 3. Now we have to solve this equation by using first principle. For that, let's del y and del t be small increments in y and t respectively. Then we can write equation 3 in terms of del y and del t as exponential y plus del y is equal to t plus del t. Let this be equation 3. Okay, now we have to subtract equation 3 from equation 4. Subtract equation 3 from equation 4. After subtracting, what you get is exponential y plus del y minus exponential y plus del y minus exponential y is equal to t plus del t minus this t. Okay, here this t and this t cancels out, and you can take out common exponential y from these two terms, and then we are left with the exponential y times exponential del y minus 1 is equal to del t. Okay, now there is del y inside this exponential function, so we have to divide this equation by del y. Meanwhile, I think you get question here, why don't we divide by del t? We can divide by del t, because if you divide by del t, on the right hand side you will get 1. Del t divided by del t is 1, and you know there is a del y inside this exponential function, so we have to again suppose little bit. This process will be little bit complex, so for simplicity, let's divide this equation by del y, both side by del y. Then we get exponential y times del y minus 1 whole divided by del y is equal to del t divided by del y. Now take limit as del y tends to 0 on both sides. Taking limit as del y tends to 0 on both sides, what we get is y exponential del y minus 1 whole divided by del y, and here you can write limit del y tends to 0. This del y tends to 0 is equal to limit del y tends to 0 del t divided by del y. Now, since this exponential y is independent of del y, we can take this out of the limit. So let me take it out of the limit, and there is, after that, limit del y tends to 0 exponential del y minus 1 divided by del y is equal to, and you know, this is dt by dy. Limit del y tends to 0, del t by del y means dt by dy. Okay, and you know, this term is in the form of, you know, limit x tends to 0 exponential x minus 1 divided by x, and it equals 1. Okay, so we have to use 1 here. Then we are left with exponential y into 1 is equal to dt by dy. This is nothing but dy, exponential y is equal to dt by dy. Let this be equation 5. Here we got exponential y is equal to dt by dy, but you know, y means the given function. Y means the given function here, y is equal to log of sine x by a, and our variable, actual variable, is x. So we have to convert this dy by dt in terms of dx. So let's do that. For that, we have exponential y is equal to dt by dy, and you can write here dt divided by dx multiplied by dx divided by dy. See, this is given function and this is our original variable. So dy by dx we can find out from here, dy by dx. For that, you have to cross multiply with this exponential y. After cross multiplication, what we get is dy by dx is equal to 1 by exponential y multiplied by dt by dx. Let this be equation 6. You know, I took this dx by dy here, okay, and it becomes dy by dx, and I took this exponential y on right hand side as 1 by exponential y. This is nothing but cross multiplication, okay, simply, and dt by dx is there. Now we have considered dt means t means sine of x divided by a. So here you can write the value of y. So d by dx log of sine x by a. This means derivative of given function with respect to x is equal to 1 divided by exponential y is log sine x divided by a times d by dx, and t is, you know, sine x divided by a. We have suppose t is sine x divided by a, and after using the property of exponential log x is equal to x, from here we get 1 by sine x by a, and d by dx of sine x by a is there. Let this be equation 7. Now from here we have to also find out the value for this term d sine x by a dx. Okay, for that we have you know, t is equal to what? Sine of x by a. We have t is equal to sine of x by a. Similarly, as we did in case of this y and t in equation 3, we suppose del y and del t is small increments. So similarly we have to consider here del t and del x is small, del x are small increments in t and x respectively. So let's suppose that del t and del x are small increments in t and x respectively. Okay, after supposing this, we can write, let this be equation say 8, t is equal to sine x by a. we can write this equation in terms of del t and del x as t plus del t is equal to sine of x plus del x whole divided by a. Let this be equation 9. Now we have to subtract equation 8 from equation 9. Subtract equation 8 from equation 9. Then we get, this t and this t cancel out. We are left with del t is equal to sine x plus del x divided by a minus sine x divided by a. Now we have to multiply by del x here, because we have to we have to find out the value of dt by dx. So here is d. If you divide it by del x, then there will be del t by del x, so that we can easily find dt by dx. So let's divide both sides by del x. Then we get del t by del x is equal to sine of x plus del x whole divided by a minus sine of x by a whole divided by del x. Okay, here you can convert this, use the relation of sine c minus sine d is equal to 2 times sine c minus d divided by 2 and cos c plus d divided by 2. Okay, in case of this relation, this is c and this is d, you can suppose it, and let's use this relation here. Then we get del t by del x. Del t by del x is equal to 2 times, 2 times this 2 times sine c minus d means c minus d. So it is x plus del x divided by 2, okay, divided by a minus x by a whole divided by this 2, okay, times cos x plus del x divided by a plus x by a whole divided by 2, and here you have to write whole divided by del x as well. Now there is 2x 2 times sine. If you separate this x by a plus del x by del a, and x by a cancel out because there is minus, and here we can write 2x plus del x divided by a. Let's do that. It is del x by a is remaining here, and inside cos x we have 2x plus del x divided by a, and this 2 comes here. This is written as 2x and 2a whole divided by, it is del x. This 2 means this 2, okay. Now let's take limit as del x tends to 0 on both sides. We get del t by del x. It is limit del x tends to 0 is equal to limit del x tends to 0. It is 2 times sine of del x divided by 2a times cos of 2x plus del x divided by 2a whole divided by del x. Now this term becomes, on left hand side it is dt by dx, and on left hand side this you can take out this cos 2x plus del x whole divided by 2a out of this limit. Okay, let's do that. So, or from first principle of derivative, limit del x tends to 0, del t by del x is dt by dx, okay, and you can take out that cos 2x plus del x divided by 2a out of the limit as 2x plus 0 divided by 2a, and limit del x tends to 0, 2 times sine of del x divided by 2a whole divided by del x is there. This becomes cos x by a, because 2 to cancel out here, and limit del x tends to 0. Now you have to arrange here, sine, there is del x by 2a inside sine function, and you have to convert it as to the standard relation as limit theta tends to 0 sine theta divided by theta is equal to 1. You have to convert this factor as this one, inside sine this is theta, and it is on denominator is also theta, and theta tends to 0 is there. So you have to convert this in same way. So for that, sine del x by 2a is there in numerator, and denominator let's take this 2 upon this like this, and we have to add a here, a multiply by to cancel this a, we have to add a here, and similarly del x divided by 2a, we have to make it as del x divided by 2a, because as del x tends to 0, del x divided by a also tends to 0 if you put del x here, del x is equal to 0 here. So now we have dt by dx is equal to cos x by a, and it is now 1 by a comes out, limit del x divided by 2a tends to 0, and it is sine del x divided by 2a whole divided by del x divided by a, and this is nothing but it equals to 1. Okay, let's write this. Dt by dx is equal to cos of x divided by a times 1 by a into this is 1. Okay, so t is sine of x by a, so you can write here d by dx, and t means sine of x by a, and it becomes 1 by a cos of x divided by a. Let this be equation 10. Okay, now we have found d by dx sine x by a is equal to 1 by a cos x by a. We have to use this relation in equation where? In equation, it is in equation 7. Okay, because here see given function is this, and we have found like this, and we needed to find d by dx sine x by a, and we have found d by dx sine x by a is 1 by a times cos x by a. So let's use that one here, equation 7. Okay, use equation 10 in equation 7, we get d by dx, it is log of sine x by a is equal to, there is 1 by sine x by a, and we have found 1 by a cos x by a in for d sine x by a whole divided by dx. So derivative of dx, derivative of log sine x by a with respect to x is equal to nothing but 1 by a, and this is cos, this is sine x by a, so cos by sine means it is cot x by a. This is the derivative of the function log sine x by a. In this way you can find out the derivative of given function log sine x by a, which becomes 1 by a cot x by a. It is little bit difficult to find the derivative of such function from first principle. So I hope you found this video helpful. Similarly, you can find out the derivative of, for example, log cos x by a and log tan x by a. These are the functions which are frequently asked in examinations. So you can try finding the derivative of these two functions as well by following the similar pattern. Okay, thank you so much for watching video.